All right, so we've explored confidence intervals in general in the wild and how they arise. But the question now remains, how do we construct one? And what do we mean by acceptable risk in our confidence interval failing or succeeding? So remember that our target, what's our objective? Our objective is that our parameter, theta, whatever it may be, lies in the confidence interval that we construct. So, for instance, as we discussed, if we had a confidence interval for our proportion of US adults that want to get vaccinated or not. So we had our point estimate of 0.69, but we also had the lower bound, so lower bound of, I believe that was 0.67 roughly, and our upper bound was 0.704. The 6.7 would probably had something else attached to it, but I don't remember at this moment. So the idea is our point estimate is the anchor for our confidence interval, and we're hoping that our actual population parameter, which is fixed, by the way, we can't change that, right? The only thing that's random here or that's subject to fluctuations is the confidence interval itself. Okay, that's terrible. There we go. That's a little bit better. And here's our actual parameter, right? Maybe it is 0.70, but we don't know, right? So every confidence interval has a confidence level. What we mean by confidence level, which we denote 1 minus alpha, the Greek letter alpha, is the probability that a randomly selected interval, confidence interval of this length and sample size around the sample statistic actually contains the population parameter that we're looking for. So in other words, it's the probability that our confidence interval is successful, that it contains this population parameter. The issue, though, is that the way that we want to think about this is our population parameter doesn't change, right? That's not subject to fluctuations randomly, right? This is theta. And every time we take a new random sample, we have a new different estimator. So every confidence interval is based on, so confidence interval depends on our sample size, our point estimate, and the confidence level. So maybe this is a confidence interval that we have. It's anchored by our estimate, or sorry, I'll call it capital T. And so if this interval matches, so it lands where this blue line is going through it, right? Then it's successful. And you can do that randomly. So here's another one. Here's yet another one. This one has a smaller sample size. But okay, we'll keep going. Here's another one. Here's another one. These are random. I'm simulating, right? But every so often, you get one that doesn't contain or doesn't cross that line. How often? That is determined by the confidence level. So maybe out of every, this is not, obviously my picture isn't very representative here, but maybe out of every 100 confidence intervals, each randomly obtained, then 5 of them fail. So they don't contain theta. Then our confidence level would be the probability of success. So 95 of them are successful. So 95 out of 100. That'd be 95%. And the alpha then would be 0.05. In other words, we get these two dueling probabilities, so they're complementary. So we have the confidence level, which is R1 minus alpha, and alpha. Alpha is the probability that a randomly selected confidence interval does not contain a population parameter. And we'll come to call this level of significance. But this is a term that we reserve for a later chapter. In other words, we are not guaranteed when we construct a confidence interval that it will actually be successful, that it will contain our population parameter. But in general, the higher the confidence level, the better the estimate. So as the confidence level goes up, right? Let's say from 0.90 to 0.99, right? Our estimate gets better, right? So more likely to contain theta from less likely to. And there's a trade-off that we'll discuss with margin of error. So remember, the margin of error is the maximum error of our confidence interval. So margin of error, we can now make this precise, is the maximum tolerance or radius of our confidence interval. So in the context of what we discussed before, right? So we said our confidence interval was something along the lines of between 0.675 and 0.704, right, is our population proportion, with our point estimate (0.69). So what we're saying is the margin of error being our 1.6. If it was 1.6, then this was not. It would have been that. Sorry. In terms of percentages, it's 1.6, but 0.016, right? Then that means that's a 6, sorry. Then that means our point estimate, it can only be off by up to 0.16, so higher or lower than the actual population parameter. So it determines how wide the confidence interval is. And so there's another trade-off here where if the margin of error is higher, right, so larger rather than smaller, then how precise or how likely it is that we contain the theta. So if it's larger, it's also more likely to contain theta. And smaller means it's less likely to contain theta. But smaller is better because it's more precise, right? And this would be less precise. So, of course, there's a trade-off between all three of these things, right? So, how good our estimate is, right? Precision. The margin of error, right? We want that to be smaller. And the confidence level, we want that to be higher. And that's a very, that's a higher level conversation that we're just getting a peek of here. In the next section, we'll actually discuss how to construct a confidence interval for these different kinds of population parameters, and they have different methods.